Hey, Ronaldo.
Hi, how are you?
Good, how are you?
Oh, fine. Hello.
Hi.
How's it going?
Fine. Hello, hello.
Okay, I'm just opening up my Excel stuff.
Okay. I'm ready to start. Isaac, quietinho. Ó. Are you prepared to the exam?
Yeah, I'm just got everything opened up. Or
Alrighty. Yep.
I will start with number 2. Which of the following variables are categorical? The number of animals in a zoo is categorical.
For me, the second and third option. What do you think?
Selected random and randomized. Categorical is like the categories, and the quantitative, is that the opposite one? Was quantitative?
Yeah, so quantitative is something that you can measure, and then categorical is something without a number measurement to it.
Oh, that's right.
Non-numerical.
So it would be 2 and 3.
Yeah, that's the same for me.
Yep.
Okay.
Yep. I can do number 3.
Yes.
Okay, the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is true? So I said that 112 was the statistic, and then 100 is the parameter.
Yep.
Yes. The first 100 is a parameter, and 112 is a statistic, correct?
Yep.
Okay. That's the same.
Yeah, I can do number 4. So Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? And I had put a stratified sample.
Yes.
Okay. Ronaldo, did you want to do one? Did you want to do number 5?
Okay, question 5. When the design and experiments are conducted in a public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the select classes. Which type of sampling scheme is implemented? Let me see. Let me see. Just a minute.
You're okay.
Maybe. What did you put?
Isn't it the systematic random one?
Yes.
I could be wrong.
I had thought
because-
it was cluster because
Yeah, for me, yeah.
yeah, because they choose, so it's within the public school systems, they choose a particular district and random teachers in that district. But within each of those teachers, then they do all of their students.
No, you're absolutely right. So I was stuck on the word fourth. So like meaning that I didn't read the full question. So I was thinking that they took the fourth.
Oh, the
Oh,
fourth student?
yes.
Okay.
Yep. So you
Okay.
were absolutely right.
All right.
Sorry.
I was worried for a second.
Nope. I have a cold, so nothing is getting through my head. So you go for it.
So
All
cluster.
right.
Yeah, cluster.
At a
Cluster-
school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which of the sampling schemes was implemented? So is this the simple random sample?
That's what I put, but I don't know if I'm right or not.
That's what I thought as well. Just because out of the, I mean, it's everyone, but it's random of this.
Yeah, they're all, yeah.
Okay.
So I
I
put,
like
yeah,
it.
the simple random sample. So
Okay.
A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? And I put stratified.
that's what I
Perfect.
put as well.
Okay, cool.
Okay. All right. So the survey was taken of purchases at the crossroads. Using that data file, answered the next 3 questions, which when I did it, I did not round to 3 decimal places. But when I got the mean, I got 4.77, and then whatever the next one would be. Does that sound right to you guys?
I haven't done that one yet. And we are doing,
So it'd be 4.771 is actually what I get. So
771.
yeah.
Just a minute. Let me do the calculation. Yes, 4.771. That's correct.
seven one. That's what I. Oh. Okay. So then the standard deviation would be 1.91.
So
1.912.
so we have to round it to 3 decimals. So it'd be 1.912.
912. That's correct.
Yeah.
I have mine rounded in too close. Let me. There. Okay. Fixed it.
So 1.912 for question 9.
Yeah.
And then I guess we just put true for question 10.
Yep.
Yeah.
I mean, it's in the software as
Really
being
quick.
the histogram, but
Yeah.
Um,
Do you want me to do the next one or?
research thought. Oh, yeah. Go for it.
Sorry, what?
I think she was just telling you to go for it.
Do it.
Oh,
Sorry.
okay. I didn't know if like that one was like kind of mine, so should I do the next one or not? Okay. All right. Jessica Muir and her research team measured.
Sorry.
No, you're totally fine. And her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the hepatic sinus of 4 of the seals, and those are their names. The seal's body temperature at the start of the dive was calculated to be the following data. Complete the following table and use your work to answer the next 4 questions. Okay, so I didn't get to this part, so I haven't done it yet. But when it says A in the quotations,
Mm-hmm.
is that like
So
what their answer is, or
yeah, so for question 11, we have to solve for A.
oh,
And then in question 12, we have to solve for B.
gotcha. So
What did you put in question 11?
So in 11, I have it done. I'm not positive about it, but I had put that it was negative 0.165, but I want some verification on that.
165?
Yeah, so negative 0.165.
0.165. Yes.
Yeah, I'm not positive though, so let's wait for some other.
This
And question 12, B.
I think we're just double checking question 11.
Oh, how did we do this?
Can you like walk me through what you did?
Yes, so it
Jeffrey?
took me a little bit to figure it out,
Yeah.
and it was really stupid and made me mad. But so what I did was you have to come up with what the mean is of the initial data, and so it is. So you add up the initial 4, and then you obviously so you add them all up, divided by 4, and the mean is 38.075. And then in that second column, where it's talking about deviation from the mean, that X with the line over it, that means whatever the mean number is. And so you take, for Bodil, Roberta, Larry, and Per, for Bodil, you do 37.91 minus the mean.
That you just found.
Yeah, that you just did. And then you can do that for all of them. And that's
Sorry, people.
how I did that. And so, yeah, so assuming I'm doing that correct, it should be negative 0.165.
Okay. Let me just plug it in. Yeah,
Okay, yeah, I got negative 165.
that's what I got too.
Negative 0.165.
Yeah. Yeah, negative 0.165. And then basically for the square deviations is you
And
just
then
take that number. So yeah, so for the square deviations, you just take that deviation from the mean and you square it. And so
You take the negative 0.165 and square it.
and you should get 0.027-ish.
That's what I got.
Okay. But then we have to solve that for B, which is Roberta's number instead of Bodil's, which is fine because we just do that same process of that 37.25 minus the mean, and then we take that and we square root it.
Sorry, people,
Oh, no, it's all good, Ronaldo.
because my wife is not in home now, and
Okay,
I'm
so-
with my two children.
Okay.
No worries.
What the answer did you put in the question number 12?
So we're still working on that, just sort of explaining things as we go. But Danny, did you have a question? It sounded like you were about to say something.
Yeah. So part is maybe I'm not saying that right. I'm trying to get my calculator. So the next part is to find the square root of the -5, right?
Well, so you square it, and so you multiply it by itself, is what it is. So like for the negative 0.165, you multiply that by negative 0.165.
What question are you solving this moment?
11 and 12 right now.
Okay.
We're just sort of going over it.
So for question 11, we're going to put -1.165 and question 12, 0.027.
So it'd be question 12. So question 12 is asking for B, which is the square division for Roberta, not Bodil. And so,
Oh, duh. Okay.
so I did them all because we have to have them for number 13 as well. So I'm using Excel, which is nice, but it's 0.681 for question 12.
Class 12,
Yeah, I got that too.
0681.
Yeah, 0.681.
Yes, that's the same. Okay. Tá.
All right.
Quarto. Quando eu acabar aqui, eu impresso pra você.
Oh, we lost Danny.
Yeah, I just noticed that.
Assim que eu acabar aqui, eu te dou um call. Tipo, é rapidinho, espera.
There she's back. Okay.
Sorry.
That's okay.
So,
All right. So Danny, did you get how to get the answer for number 12?
Yes. Yeah.
Okay. And so we got 0.681 on number 12.
Yeah. Are we?
And then for 13, this is one I had a question about actually, so I'm not positive.
Okay, the quantity is okay. What is the is equal to the sum in the square deviation column?
So the sum of those numbers is 1.5341. But it asks what quantity is equal to that. And the mean is 4.7. The standard deviation is 1.9, and the variance is 3.6. So I put that it was D. None of these is correct. But I feel like you wouldn't ask that unless one of them was correct. But based on what we did, none of them are correct.
What did you?
Maybe it's not the
My
variance.
internet
What did you say? The,
freaking out.
oh,
What did you say? Say that again. I'm sorry.
No, that's okay. So I did the squared deviations column for all of them, and it's so the sum of all of those, what it adds up to, is 1.5341. And then it's asking us what that number is equal to, which of these three numbers. But based off of what I put in on our quantitative descriptive statistics page, it gives us that none of them are correct, which a little bit worries me, but like I feel like we did the math correctly. So I'm not sure if it's D or if it's one of the other three. I think it's D, but
Okay, so because on those tables you can do more. It seems like I can't. Oh God, I wish I took better notes in the first
Maybe it's not the variance.
weeks. Let's see.
because like it's even if you double it, like it still doesn't equal anything. I was just curious, but yeah, so like it doesn't equal any of the specific numerical descriptive statistics it gives us in this Excel sheet. And so my guess would be D, but once again, I'm not sure. I'm not positive about that.
Let's just see here. Let me just double check something else. Okay, so I agree. I think it's none of these is correct.
Okay. That's what I thought. I just didn't want to be the only one.
What I was thinking of is after you square it, find the standard deviation for that amount. Doing that. Let's see, graded table standard deviation. Sorry, I'm not explaining this very well. I'm just looking back for our old lessons.
Mm-hmm.
I'm good with it. Yep.
So D, none of these is correct on 13. Okay.
Yep.
Alrighty. And then
so question 14.
14, let's go.
Yep.
Okay. Ronald, did you want to take this one?
Okay. What is the standard deviation of these temperatures? I guess 0.715.
0.715 is what I got as well.
That is what I got.
And then who's next?
I think I am. I think I go after Ronaldo. Under certain conditions, a standard deviation can be negative. Like, that is more of a question than a statement.
So based off of the formula
No.
of it, I would say
Can't.
no. Because
Yeah,
when you take the square root of it, it automatically makes it positive.
Yep, I just tried it.
Yes, for me, false.
So no. Or false.
And as well, just, I mean, this is sort of what I thought of when I did it is when you're doing the standard deviation, your standard deviation, you put it in a positive number, but it works on both sides of the mean of the numbers you're working with. So you might use it in a negative way, but it's always a positive number. Is what that's how I thought of it.
No, that's a great way of thinking about it.
Okay. I can do this next one. So in that same study about the diving seals, the researchers placed thermistors in the 3 seals named Chick, Starburst, and Patty near their spinal cord and brain and extradural vein. They placed thermistors in 6 other seals in their aorta, the largest artery in the body. Finally, they placed thermistors in 4 other seals in their hepatic sinus. The results from this study are summarized in the table below. So the first question is, which location resulted in the most consistent temperature measurements from one seal to another? And so I had put the extradural because it has the smallest standard deviation. So that means the numbers look.
I agree.
Yep.
Yes.
Okay. The number of hours students spent studying for an exam were recorded. The data are represented by the box plot below. Use this box plot to answer the next 2 questions. What is the third quartile Q3? So that would be 8?
8. I agree.
Yep.
Yes, 8.
Cool.
Ronaldo, do you want to do the next one?
Okay. What percentage of the data lies between 4 hours and 8 hours? Note, list the number as a percent and not a decimal, and don't include the percent sign. Okay, what percentage of the data lie between 4 and 8 hours?
Do you have any idea, Ronaldo, on that one?
No, not yet.
All right.
So I put 50%.
Yes, I think it's 50, but I'm not sure about that.
That's what I put as well. Yeah, so I put 50%.
And the
Yes,
reason
50%.
I did was
25.
because it's between 4 and 8 and half, so it's equally between 4 and 8.
Mm-hmm. And so with the box plot, each different segment is 25% of the data. And so from 2 to 4 is 25%, 4 to 6 is 25%, 6 to 8 is 25%, and then 8 to 12 is 25% of the data. In this case, it looks like they might have put in some outliers as well, but.
Yep.
So 50%.
Yeah, I put 50% as well. So.
Okay. Good.
Okay. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million. The values outside this range are unusual. We will assume that the mean sigma 2 sigma equals 1.59 parts per million, and the mean plus 2 sigma equals 2.52 parts per million. It is reasonable to assume that the measured nitrates concentration is normally distributed. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. So, I would love some help on this if somebody wants to jump in.
Okay. So on this one, what I did is, so we're trying to find the mean of what it is. And so we're given sort of two, not the minimum per se, but like the within 2 standard deviations. So what I did is I just added 1.59 and 2.52 together and divided it by 2 in order to get what would more or less be that middle ground. And I got 2.055, rounding it to 3 decimals.
Yep. Perfect. Oh, because it's asking for the mean. Oh my goodness. You're absolutely right.
Made it so much more complicated.
I know it. They added so many more words than needed to be in there.
Yeah, it's statistics.
It's terrible.
Alrighty. Estimate the standard deviation of the measured nitrate.
2.055.
Oh, sorry, what was that?
Yes, for me, 2.055.
Okay, yep, that's what we got as well. So good. So, the next one. Estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. So for that, did you guys get 0.657, 1, 2, 3, 0.657, or 8, I guess, rounded?
Got 2.
Oh.
I got 0.658 as well.
Okay, how did you get it?
Yes. How much?
So 0.658. So what I did is you take, so it's similar to what we did about the seals. So for each number, so for the 1.59, we do 1.59 minus the mean. Then we take this, we square that. And then we do 2.52 minus the mean, and we square that. Then we find the mean of those, and then square root that. Right, Hannah? Sound right?
Yes.
And what did you guys get?
0.658.
Okay. I think that's what I was trying to explain on our previous problems when I was talking about squaring the, or adding the, finding the standard deviations of the squared amounts. Okay. Who wants to do 21?
I can.
Okay.
Between what two measured nitrate concentrations do approximately 68% of the data values lie? And so for 68%, so on this one, so that's within 1 standard deviation to both sides, right?
Mm-hmm.
I am now thinking 2%. So I would say it would be the first one because that's the one that my numbers are closest to, but I probably did it slightly wrong. So I don't know on this one.
Probably the last one.
Okay, so I have, it's approximately. So
Okay.
for the 1.59, because it's it's the first range, I added 0.658 because that's 1 standard deviation.
Mm-hmm.
And I got 2.248. So I would say that would be.
For me, it's the last one. Because just one.
2.288.
Because if one subtraction just one standard deviation, we have 1.823. And adding just one, we have 2.288. For me, it's the last one.
What did you use for your standard deviation?
For example, we have the mean, in the formula. The mean is 2.55. Minus 2 standard deviation equals 1.59. Using the 2.055 in the formula,
Yeah, so, but the 1 standard deviation is actually, so for number 20 is 0.658, I think is what we had put. And so we need to use that even though it's with that those numbers are within 2 standard deviations, we use the 0.658. And I get 1.397 for the bottom number is what I would get. And then and I would get 2.713 for the top number.
Are we allowed to use the Excel file, the quantitative descriptive statistics one?
Yeah, I can't.
Yeah.
I don't know why not.
We're allowed to use that on the test, I'm pretty sure.
So for quartile 1, it says 1.8225, and quartile 3, it says 2.2875, which
would give us the bottom one.
Yeah.
Okay, so hang on just a second. Control Shift down. What did you put? Oh, son of a biscuits. Sorry.
No, you're fine.
What numbers did you put in your quantitative to get like your standard deviation? Did you put the 2.52?
And 1.59, yeah.
And the 1.59. Oops, too many nines. Okay, so 1.8225.
Yeah, rounded up to 3 decimal places. That's exactly what it would be. It would be that 4th one.
Yep. Yep. Because this. Oh, yes. That's a good way of taking your standard deviation. Perfect. Yes.
Cool. So it's one. So it's that bottom one for question 21. Okay.
Yep. Good job. or okay. I can do this one. Sorry. The admissions committee for most masters of business administration to be MBA programs require that a graduate management admission test GMAT as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for the admission to the MACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student will score above 542.3? So we need to find the Z-score.
This one's pretty simple, actually, as far as how I understood it. Yeah, so this one specifically. The other ones, you actually have to calculate the Z-score, but on this one, so it asks what the probability that a randomly selected student will score above the mean, because that's the mean. And since the mean is that middle number, wouldn't it just be 50% statistically? Because it's standard, where does it say? It said it is normally distributed with a mean of 542. So it'd mean there's a 50% chance that someone will score above 542, right? Or am I wrong?
I don't know, because I can't figure out how to test that in my brain. Do you mind if I take a minute and just do a Z-score? Because you could probably totally be right, but that's the only way I know how to check it.
That is totally fine with me.
You know, I totally think you are right, because
So the Z-score should be 0.
yeah, because the Z-score is 0. Oh, yes, you're absolutely right.
Okay. Want to make sure.
I wasn't thinking that the score above 542.3 was still the same mean. Sorry.
No, that's fine. That's why we're in groups. We want to make sure we can help each other out about that. So
You put 50%?
So I did 0.5 because it's asking about probability versus percentage. So
0.5, that's right.
And then 23. I can do 23. So what is the probability that a randomly selected student will score below 600? Scoring below 600. So assuming this is the exact same as what was on the review, which I'm pretty sure, but I think I got 0.684, but I want to recalculate that just to make sure.
That's just what I got.
0.684? Okay. I don't feel the need to recalculate that.
Can you walk me through how you got that?
Yeah, so in order to get that, you need to calculate the Z-score for 600. And so you do 600 minus 542.3 divided by 120.54. So 600 minus 542.
So that gives you a Z-score 0.479.
Oh, and then you put it in the applet.
Yep.
And the way I am now learning the applet, it's because it was confusing me on where to put my blue line, and it's anything below that first line, that first red line, so to the left.
So the red line is 600.
Yeah, that red line, the first one would be the Well,
because the right line in this case is 600 because it's above
Yeah.
the mean. And so that's sort of how you can know. If the number that you're working with is below the mean,
It's
you
the
know it'll
left
be
one.
the left red line. If the number you're working with is above the mean, you can know it'll be the right red line. And from there, you can determine below or above of that line.
Got it. So you shade the middle and the left, and you got 0.684, right?
correct.
Yep.
Okay, that makes sense. Thank you. Okay. I can do the next one then. What is the probability that a randomly selected student will score 600 or above on the GMAT? So then 600 or above. So that's just right of the red line, correct?
Mhm.
So it's 0.316.
That is what I got as well.
Cool.
What is the answer you put in 24?
0.316.
316. Yes, that's what I put. 316.
Okay. And then do you want to do number 25, Ronaldo?
Yes. Find the GMAT score that corresponds to the 10th percentile. Oh, I forgot the formula for this question. You have the formula?
Okay, find the GMAT score that corresponds to the 10th percentile. So what I did was I put, and I could be wrong, 0.1 in the area, and that gives me, and we're going to the 10th percentile. So I color in that little area to the left of the red line, and I get negative 1.282. Am I doing that right?
Yes, 0.1, no? 1.2.
So yeah, so that's how you get the z-score for the percentile of the 10th, and then you multiply that by the standard deviation and add the mean, and that'll give you the GMAT.
Multiply 1.282
282 by 120.54. So it should give you negative 154. And then you add the mean of 542.3 to it, and you should get 387.7, which rounds up to 388. That's what I got.
Okay.
As in, like,
Sorry,
0.88.
Could you repeat, please, what did you do?
Yeah.
Exercise?
No, yeah. So what you do is, so in the applet, you put the area on that far left section as 0.1.
Yes.
And then you multiply, you take the z-score, which it gives you, which is negative 1.282. And you multiply that by the given standard deviation. Yeah, so the 120.54. And that gives you the minus 154, so negative 154. And to that, you add the mean. And so basically, you do the same process for coming up with your z-score, but backwards.
Why did you use the negative z-score instead of the positive z-score?
So you use the negative z-score because it's asking for the 10th percentile, which would be the lower number. If they were asking for the 90th percentile, which they do, we use the bigger number.
I see.
Okay, or the thank you very much.
Now it's So thank you.
So I got, then for number 25, the GMAT score that corresponds to the 10th percentile would be 388.
Perfect.
So what is your final result?
388.
300?
And 88.
So, 300? Okay.
388.
Okay. Yes. Let me, just a minute, please. Okay, 388.
Yep.
387.7. No, but I need to use.
You round to the nearest whole number. Yep.
Yeah, that's correct. Yes.
Okay, and so on this next one, I'll just talk about that one as well because it's the same process, just instead of that bottom area, we do the top. And so instead of using that negative z-score, we use the positive z-score on that 1 point. So we use the 1.282, multiply that by the standard deviation, and then we add the mean. And then we round up to the nearest whole number.
So did you guys get 697?
That's
Yep.
what I got.
That is what I have. Perfect.
697.
Okay. So find the first quartile of the distribution of GMAT scores. I'd love some help on this one.
Okay.
Yes.
So this one is actually the same process as that last one. The next
Okay.
two, so 27 and 28 both. So the reasoning is, so we, instead of wanting to find the 10th percentile, we find the 25th percentile.
25th percentile.
And then
Yeah,
the
okay.
75th percentile for 28. And so then it's the exact same process, but you just have to translate first quartile into 25 and then third quartile into 75.
75, that's correct, yes.
So I get, for the first one, 461.1 or 461.
So just be 461 on that, 27. Yep, that's what I have.
Sorry, what result did you get?
It's 461.
461.
461. And then on 28, I'll wait for you guys. It's you ready.
461, right?
Yep.
Okay.
And did you get 623 on the 75th percentile one?
So 75th, I got
For the third.
620. Yeah, so third quartile, I got 623 is it 0.4, right?
I got
is what I got.
623.54.
So 0.54. Okay, so yeah, then we rounded up to 624.
That's what I meant. 624. I'm not rounding very well.
I got that as
Yes,
well.
please. Just a minute. What result did you put in the question number 28?
It's 624.
624.
624.
Correct. 29.
So 29 and 30, I was not sure on the last three.
Okay, I get these for some reason.
Perfect.
So let me just plug in my formula. So maybe. Let me see. Oh, consider the random sample of 15 students taking the GMAT. What is the mean of the distribution sample mean scores of such? So well, I get them when they have more than just this. So is this, let's see. So we have our mean, but what is our number that we're minusing our mean from? Is this the 600? Are we still using 600?
I don't know,
You
'cause
see-
like on this one it's saying of those taking the GMAT, we take a random sample of the 15, and then what's the mean of it? And I'm like, I don't know how to do this without more. I guess.
Without more numbers, right? Okay, so let's just think this through. I feel like we're missing something really big. Like, like, I'm trying to go back and look at some of our old quizzes, but even they have, you know, like a number that they're trying to get you to figure out what you're sampling from. And that's why I don't know if they're trying to get us to use, let's see, the 600. Let's see, but it is rare for students with a score of less than 600. I feel like this is kind of a shady question.
Yeah, I'm not sure. Like these were the ones that I really definitely did not understand.
Okay, let's see.
Well, the 31 question includes the 600. So maybe they do want us to use it.
Well, because that one's just dependent on the probability of the sample mean, but like, no.
Group. The question 29 may be the mean. It's not the mean of the population. 542.3.
Would it just be the same mean given the random sample?
Yes. Oh my gosh. Yes.
What do you think about?
Yeah, because that's the mean. Because that, oh my gosh. Yes. Why? Oh, yes. Because this is where that mean u equals the normal mean. Because
Yes.
it's a normal. It's a normal distribution. Yes. Yep,
Okay.
it is 542.3.
Yes, now the standard deviation, we have a formula, no?
No, the
Calculate.
standard deviation. Oh, wait.
Is a standard deviation divided by square root of the sample.
Yes.
I got 31.12. Question 30.
So for this one, when you're taking the standard deviation of the distribution of sample means, so it's you take the standard deviation that we already have for the population and divide it by the
Yep.
square root of our
Yep.
our sample size.
Correct.
Yes.
Okay.
And it is 31.12.
So it
Yes,
wants us to
31.
round to 3 decimal places. So
1, 2, 3.
you're
1,
doing
2,
3.
3. That's correct.
Okay. So then,
Sorry, so you put
So then-
31.1 or what?
2. That's for number 31.123 is for question 30.
31.1. What was the last?
2, 1, 2, 3.
Oh, maybe it's just the way around.
Yes.
Okay. 31.123. Okay. Thanks.
And then let's see. So then for the probability that'll be greater than 600, I have a z-score of negative 1.680 that I'm going to plug in.
So let's put the formula to find the z-score. No,
Yeah,
e
and it's
should
greater than 600.
divided by.
But so to get that z-score, I took 6. Oh, that's why I'm not getting the right answer. I have too many numbers. So I put 600 minus 5. Oh my gosh, I didn't even have the other right. 542.3. I get 1.854 for the z-score.
Mhm.
1. And we want above 600.
Mhm.
So I think I have 90.968.
So that would be if it was everything else. So instead of doing the left
Oh.
of that red line, you want to do the
It's-
right.
Oh, yep, you're absolutely at 0.032.
Yep, that's what I got.
Sorry, is the z-score?
Z-score is 1.854,
Yes,
Which then-
1.854.
which then if you click the section to the right of the right line, the right red line, it gives 0.032 as the percentage, the probability,
0.032, right?
0.032, yes.
Yeah, 0.032.
Yep. Okay,
All
that's
right.
it then.
I'm saving all answers or saving all responses. Go to
Good call.
submit. Submitting my quiz. Yes, I want to submit it.
Click submit 17 times.
Yes.
We got a 92.48. Let's see. We missed. Estimate the standard deviation of the measured nitrate concentration drinking water.
92.4.
And
Yes.
oh,
Commit mistakes.
how did we miss that one? What percentage of
Yes,
the data
but,
lies between 4 and 8 hours?
I know the mistake in question 20 and 21. I think so. No,
You do?
because, for example, we have a mean. No, we have a mean that in the question 19
Mhm.
at 2.055. Applying the formula above, no, we have the mean minus 2 standard deviation equals 1.59. No, So once we have the mean, we need to put in this formula. We will find the standard deviation. 2.055 minus 1.59. No? Divided by 2. No? The standard deviation is 0.2325.
Yep.
Okay, I didn't get that.
Which question is that?
So for 19 or for 20,
I
because
see.
that's talking about the city of Rexburg, the nitrate concentration, that stuff. So we got it wrong, the standard deviation wrong. So we take our mean and we do, so the formulas it gives us is, so for 1.59, it's the mean minus 2 standard deviations equals the 1.59. So what Ronaldo was saying was we do the mean minus 1.59 divided by 2, and that gives us the standard deviation, which would be 0.2325.
Yes, that's correct.
So that's where that one was wrong.
And the question number 21, the correct is the last one. 1.823 and 2.288.
Yep, that's what we ended up getting as well. So that's good. And then one that we got wrong that was number 2. So talking about what variables were categorical. So I think the age in years of randomly selected vehicles, it's talking about the age, not the vehicle. And so I think we were thinking about the vehicle for number 2. And so it would have just been that middle one, I think.
I agree with that.
Yeah.
But other than that, but you said you had gotten, what one had you gotten wrong, Danny, that you were confused about? Because it was, one.
Oh, it's 18. What percentage of the data lies between 4 and 8 hours?
What did you put?
I put 0.5.
Yeah, so he said to input it as a percentage, not a decimal. And so you had to put 5 or 50 in that case. So
you know what? I'm going to retake this really fast. I'm just going to leave. Let's see, paste and go.
Because if this is the grade I get on the test, I'm going to be a very happy person.
Right. Okay.
There is another mistake, in question number 2.
Yep. Mm-hmm. And so that one, we put the bottom 2, so the randomly selected brand of toothpaste, as well as the age and years of randomly selected vehicles. And so it only should have been the toothpaste, not the vehicles, because the vehicles, the actual variable is how old the cars are. And so that is a quantitative variable, not categorical.
That's correct. Yes.
That's where that issue is.
Yes.
But
so let's redo the activity.
Yeah. It's not that bad. So.
Yeah. You did a great job.
Yep.
Yeah, let's see here. Okay, so I don't know. I'm going to retake it. I don't know if you guys want to.
I'm not going to. I'm fine with that. I'm very happy with that, actually.
Perfect.
Okay. But if we don't have any more questions, I'll get going. So.
No, I will post this.
Perfect.
Awesome. Thank you, Danny.
Yeah, thanks so much. We appreciate it.
Yep.
Yes.
See you guys.
Good luck on your exam, guys.
Yeah, good luck.
Yes, good luck, you guys. Okay.
Bye.
Yes, you too.
Bye.
Bye.